Well, if red check marks are any indication of how close we're getting to the end of this project, I would say that we're pretty close. Anything that is not checked off is apron related, and that is this subassembly right here in the front. It's got a half a dozen pieces. It's going to be a little fussy to line up, actually, because it has to line up the drive shaft at installation. So that'll be another video for sure. Let's start with making all these little components. First one in line, number 19, and I believe that is the clutch knob. It'll be a fun little part right there. Shaft collars are next, made out of the same material the clutch knob was just made out of. These are simple shaft collars. There will be two pieces coming out of this little slug right here, and in a setup like this, you have multiple choices you can make. You can zero out on the inside of your stop, offset for the first hole, calculate the length of your part, and just shift accordingly for the second hole, because I'm going to cut one piece off of each end. Or zero the face, cut it, flip it, bank it again. It's already on location, drill it. Or you can zero the outside edge and do the exact same thing. For sake of visibility, I'm going to zero the outside end and flip it. When I flip it, since the length of the part doesn't change, the end on the opposite side ends up in the exact same position. So this should be rather easy. Let's take a quick look at the positioning of the apron and why it is so critical. Let's find the casting. Here's the casting right here. These are gates on top and they will ultimately come off. You must work from these elevations here because you can't change the location of those elevations, so they're very important. So they have to be factored into whatever's going to happen next. This thing has to attach to the bottom of the carriage. Move back and forth. Now on the inside of the apron, we have a couple of drive gears. We have one sitting there. That would be the hand wheel gear. And this little guy right here, this is the clutch mechanism for when you engage the power feed. I think anybody with a south bend will recognize that particular configuration for the clutch. Anyway, when it's tight, these guys move in unison. When you unloosen it, this one on the inside is allowed to freewheel from the rotation of the lead screw or the drive shaft. And when you torque it down, it then moves the carriage. And they engage by a cone. There's actually a taper on the one and a taper inside the other one. So when any pressure is applied, they just simply bind up. But it's not a very mild taper, and that's good. If it was a mild taper, it might want to press and lock like a Morse taper does. But this is a 60-degree cone, and when they're not under pressure, they're very cooperative. Anyway, this guy also sits under there. This is just getting too small to touch. There you go. Okay, now I think it's pretty important to see right now, or very clear to see, how the center line of those two features, those two holes in this apron need to line up perfectly with this apron in order for the gap to be correct from the underside of the carriage to the center line of each shaft. And I am going to cheat when I do this, 100% cheat, and I think it's a great way to do it. So anybody wants a copy, have at it. I'm going to set my bed up in the machine. I'm going to use an edge finder against the bottom of the carriage. Now this still does flop because there's nothing holding it down right now. I'll put a pin in the drill chuck and I will space the pin back until I can traverse this bed and get this gear to walk along that rack comfortably. At that time I'll know what the number is and I'll know how far up I have to come from the center line of the apron and establish this surface right here for that to work. Don't ask me to repeat that. Holy mackerel. Anyway, there are some numbers on the print, and I'm sure the numbers on the print are good, but they're also very conditional. If the height of your bed V features is high, low, if the notches in your carriage are too deep, not deep enough, this whole assembly will lift. And if you use those numbers, you may bind these gears right here and be very disappointed at the very last minute of this build. Been a lot of work here. I will not take any chances. I will make sure that the numbers I'm going to use are correct based on what I have here. All right, let's set this thing up in the mill and I'll show you exactly what that just meant. The bed and the carriage upper is very gently squeezed in my vise right here. And when I mean gently, I mean 2-finger pressure on the knob that tightens down the movable jaw. Now this is on a pivot, so I just want to show you how that's squeezed in there. Single parallel against the machine flat side. And I'm going to swing this back into position right in line with the bottom of that carriage. This is the dimension I'm looking for right there. I'm going to show you how I'm going to do it. That is a 125 diameter pin in a 125 collet. And as the whole assembly shifts to the rear, to the camera left right now, this gap will get smaller and smaller. So I'm going to move it until I like what I see. Okay, minimal backlash. Now, if all goes well, when I move the table, this gear should walk along that rack perfectly, which it does. When I get here, I'm going to check the backlash here. If anything is out of square, out of parallel, this is where you're going to see it. All right, I like it. Now with my digital readout set on 0, I can put an edge finder in here and move over and pick up the bottom of the carriage casting. And naturally with the offset based on the diameter of the edge finder that you use, I will come up with the exact measurement I need for the front of that apron to the gear center lines so that when I screw it together, it'll work. At least that sounds good on paper, right? Let's put an edge finder in here and come up with a number. That's a great way to do that. Keep that in mind. This is one of those fit at assembly moments that you don't know how to do it. So I hope this gives you something to think about. The 125 diameter pin is out, the gear is out, and the Y-axis has not been moved. I'm going to come in with my edge finder and register on the bottom of the carriage. Make sure when you do this that you don't hit any inclusions or casting gates or anything. Make sure you are banking on the same surface that the apron will bank on. So I'm shooting for right in here. And yes, I did indicate this face to make sure it's running true. Let's do it. Whatever reading you get on your digital or your dial, make sure you add the appropriate radius of your edge finder to come up with your number. Okay, 364.5 on the digital. We are looking for center line. There it is, 365. Gotta give them a big round of applause for that. That is just right there. That also indicates that many of the things that I've been doing on this model have gone right up to this point. That is going to be my minimum number. I am not going to go below that. Anything below that, you might start introducing a little bit more bind and a little bit less backlash. So I'm going to leave this as my absolute minimum, possibly stay a couple thousandths higher. Okay, every once in a while things do not come to you the way you would want them to come to you, and this particular inclusion right here in the casting, well, you know, it's to be expected. This is a mass-produced part. There was another one on this boss right here, so I took the boss lower than the print by about 15-20 thousandths-ish, and I will make a brass shim to go in there because that's where the hand wheel goes. On this edge right here, I'm going to put a large chamfer across the front, blend it in, and then re-blast it. We'll see if we can make that inclusion go away. I just can't bring myself to use another piece. I did request one. The company will probably be generous enough to provide you with one if there's something that you're not happy with, but I'm going to put a chamfer on that because it looks like a 45 might clean it up. Let's find out. I like it. A little bit of blending and rounding, another blast job. You'll never see that. I'm also going to take a dust cut, thinking about taking a dust cut across this bottom just for tooling purposes. No, maybe not. All right, let's shift it, go vertical. I'm not going to cut the bottom. I'm going to leave the bottom stock as is. I will clean this up and blast it. Let's do it. Part is successfully relocated. Never took it off the fixture plate, just hold the fixture plate vertically now. Gives me access for the two 72, actually for the two 172 mounting holes in the top. And there is a slot that goes in behind this for the clutch gear assembly that assembles through this hole right here. That may be kind of hard to film, but I'll film the threading and I'll show you the slot when it's done. This is the pocket for the clutch gear. Whatever width your clutch gear is, make sure it fits down in here. This is called out as a 125 and the clutch gear is 093, so there should be plenty of room. And I am fairly sure that that's so that you can unlock the clutch mechanism when the time comes. I'm going to put a slot right down there. It goes through one wall. All right, the apron is about 99% of the way complete. The 3 gear shaft holes are in there. This is a press fit hole. There'll be a shaft press fit in there for another gear. This is the hand wheel, I believe, and this is the clutch. There's the little slot that I put in. Mounting holes. I think the repairs came out fairly well. The chamfer did take care of the ugly on the front of it. I will blast this so it looks exactly the same as the rest of it, and I'll make a shim for this. So that is not a big deal. This will look great. Promise you. Let's take a look at the clutch mechanism. Clutch mechanism is a conical feature on one and a conical feature on the other. And if I don't get that nut, it's going to make me crazy. Anyway, when they come together under pressure, the cones bind, and that's your clutch. That clutch mechanism fits right in this slot right here. Put that together, prove it. And that is the clutch. When the knobs turn clockwise, tighten it up. Both gears spin at the same time. When you turn this counterclockwise, yeah, you thought I was going to say unloosen, didn't you? But I didn't. All right. The gears can now spin. This can stay put while this one spins. That's the clutch. Tighten it up. Now it turns. Let's put it on the carriage. Check the spacing. And to answer the questions that are going to come, no, I had no idea this thing was so detailed when I started it. Well, like anything else, if you're going to start it, finish it. Watch the knob. How cool is that? Clutch gear is 093 wide, and that slot is 125, so you do have about 0.8 millimeters of play in that. You will never encounter the face of the casting, which is good. You see the gap right in there. But there is a little wiggle in it. And whatever clearance you put between the clutch gear and the rack is going to be the lift that you're going to have on the carriage. So watch it move. Ever so slightly. Now that is going to be taken up by the drive rod that goes through here and anchors to these 2 points here. So the drive rod is going to hold the apron is going to hold the carriage, and all will end well. Getting close, starting to look like something. I am only a couple of pieces away from being done with this. I have to do the worm, the key for the worm, and the 2 anchor blocks on the ends, and 1 drilled and tapped hole here for the gear cluster that mounts to the end. And then it's time to put it together. I do thank you for hanging in. This has been a very lengthy series, but I am just thrilled the way this is coming out. Thanks for watching. I hope you're happy and well wherever you are in the world. Joe Pye at Advanced Innovations in Austin, Texas. I'm out.